Hey, this is Steven from the Green Engineers, and I wanted this to be a update video because we had a lot of things that are coming up here. Sorry, that was my cat. So I wanted to spend we have up to 40 minutes, but I don't plan on going that long at it. So we had a few points that we were going to hit here. Number one is we have Maker Faire coming up. Number two is the multi-struder. Number three is the shredder. Number four is the Ecobase, which is again a a project name. I have not come up with a final name for that. And the last one is the future. So what is in store for the Green Engineers in the future? Okay, so I'm going to try to go in as detail as I can in these subjects and to give you as much information as possible. But also, I'm starting to do a new series thing on a few of my channels. I'm going to do it as well on this one. It's called the Chore Chat, and that's when I need to do some sort of mundane kind of mindless work, cleaning or whatever. And when I do that, I generally do like a talk about a subject to shed some light on that subject. And that's called the Chore Chat. Obviously, because I'm doing two things at once, it might be a little scatterbrained sometimes, but it's definitely helpful for the time that I spend on it, and I'm getting better and better at it to where it's pretty focused. So I did a whole bunch of those. I did one on each of the projects, and they're generally 30 to 40 minutes long. I did one on the multi-struder, I did one on the shredder, I did one on the Ecobase 3D printer, and I did one on the filafactory, which we'll learn about later. Alright, so those will be uploaded to the channel soon, and those are just audio only, no video. Okay. So, number one, Maker Faire. Let's go ahead and bring that up. My other screen here. Cat's getting a little excited. Okay, so Maker Faire is May 18th through 20th. So today is April 6th, Friday, April 6th, 2018. So I think we had like 42 days left. 42 days and 3 hours left until Maker Faire. I already submitted my application. I already got accepted into Maker Faire this year. And so I am indeed going to have a booth, the standard 10 by 10 booth, probably in the 3D printing pavilion again. So this is the slate for Maker Faire this year. This Maker Faire is going to be my biggest one yet. We have gone to 3 Maker Fairs. Well, this would be the 3rd Maker Faire. I've gone to the last 2, 2016 and 2017. I have posters over here on the wall. And this one again is going to be centered around what I call the tool chain. The tool chain is a multi-struder, the shredder, and the Ecobase printer together. So it's basically being able to shred scrap plastic, turn it into filament, and then 3D print. If you don't like the 3D print, shred it, turn it into filament, print it again. So it's basically a complete factory, I guess you would say, where you could create stock materials cheaply and then be able to turn them into something cheaply on a 3D printer. And then if you don't like that, repurpose it and go back in. So basically drop down the cost of prototyping, production, whatever. Obviously production if you're using a 3D printer, but you could also use it for other things as well. For example, you could use the shredder if you want to do some sort of, you're putting something in a mold, you're pressing it. That would also work. Also, another one is you can check out like Dave Hackens, his website. What's it called? What was this company called again? I forgot. Dave Hackens. It is called. What is it called? Precious Plastics. So also you could go to their website and you could see similar designs in applications of those designs. Sorry, I'm still a little sick here. Okay. So, bringing the 3 projects. So basically, Maker Faire is huge because it's a combination of all 3 projects that I want to have all 3 working prototypes there. So the multi-struder, I want to have the finished project with the spooler and the dimensional control, which I just did a major development on development and control yesterday. I'll be talking about that in the multi-struder section of this video. I will also be preparing to start the Kickstarter for Ecobase 3D printer. And I'll go into what that is here, and also I'm going to have a short chat, 30 minutes, to be talking about what the Ecobase is. That is slated to happen in August. The Kickstarter, the production of that guy is slated for August. So the Kickstarter is going to be a month long, and it's slated to end in August. So it's going to start. I'm going to be designing the Kickstarter in the summer, and it's going to run through the summer. At the end of the summer, it's going to stop, and then I'm going to start production. Probably towards the end of summer, I'm going to start production while I'm out of school. Because I have one more year of school left after the summer, and we're going to go into what's going to happen in that last year of school here in the future at the very end of this video. So again, all prototypes running. I'm reading through my notes here. So all three projects, all prototypes running, and we're going to start the Kickstarter for Ecobase 3D printer. The multi-struder. So now we're going to run into the multi-struder. I just designed yesterday, or not necessarily designed yet, but I found an option for a better sizing for the filament. So what I decided to do is I decided to step away from the load cell that takes forces and turns them into, that will read a force, and then it'll use Hooke's law, which is involved with a spring, which is force equals K times X. K is the spring constant. It's the amount of force needed to depress the spring a certain distance. And then force times X. X would be the diameter of the filament. So that way you could solve for the K, the spring constant, known a given diameter, and you could go that way. But the problem is that the Arduinos cannot cut up that reading small enough to be able to read dimensions as small as I need it. It's just a rough estimate, and it jumps a whole bunch of values when I used it, because I think it goes up to 500 grams or something like that. Let me see if I can find it quickly, because I'm not really going to want to go too big. Okay, here it is. So yeah, this goes to 1 kilogram, and that divided by 1024. I do not think that is enough of a resolution to read it. Again, at that time, I didn't do the math on it. I just kind of found the lowest one, but should have probably went lower. So, and also those are expensive because they also need a digital up amp that will turn that from millivolts into volts, and then communicate to the Arduino digitally. Because communicating digitally, I believe, is SPI, so it needs at least 3 pins. So that's taking up a lot of pins, and also you have to have a big library to interpret that digital and turn it into an actual number. So very resource heavy, very expensive, and very hard to implement. So what I did is I found out a way of taking a slide pot. So basically normal pots they turn, slide pots they go up and down, just kind of like what you have on your stereo. Some stereos have the ones where you slide them up and down. Another thing would be on my truck, it's like the EQ, the bass, treble, and volume, I guess, is they have 3 sliders. So what you could do is actually, if you get the travel to be small enough, you could actually get it to read 0.01 millimeter, which you have a diameter filament target of 1.75 millimeters, or 2.85, or 3. So you need to be able to read down to the 0.01, so 1/100th of a millimeter, which I just did some testing on some custom ones that I had ordered from China, and I was able to do 1/5000th. I was able to read down to 5,000th of a millimeter, otherwise known as half of a 100th of a millimeter. So 0.005 is what I could read down to accurately, which is perfect for this application. And that guy, because it's a pot, you attach voltage, your full 5 volts to one side and your ground to the other side, and you attach a analog pin to the wiper. Goes right into the gives a voltage right to the analog pin on your Arduino, Just 2 lines of code, very lightweight, only uses 1 pin, etc. Let me let my cat up here. She's been in here for a while, and I locked the door, so she wanted to get out. Okay. So, and also I plan on redesigning the winder. I'm not a big fan of how this winder is working. It's really floppy, and it's hard to have precision travel. So I'm going to change how that is implemented. Haven't decided how yet, or how I'm going to go about it, or how exactly the design is going to look after I mess with it. But it's something I need to change. Okay. So I want to redesign the wiper, and of course all this has to be done. I have to finish the design of the diameter sizer. I have to finish the redesign of the winder. Get everything ready before Maker Faire, while working on 2 other projects. So pretty hard to do. All right. Then I have 6 of those to ship for the Kickstarter after I finish, which I should have. That should be my production prototype finished by Maker Faire, and then after Maker Faire I'm going to assemble them, print everything that I need, put all the electronics in it, pack it up, ship them out, finish the Kickstarter. Then the last one, I need a few people ordered expansion modules, so I need to do all the expansion modules with all this upgraded stuff, ship those out, finish that off. Then I have a fork in the road where I have to decide. What I'm thinking of doing is either upgrading the multi-struder to where it's easier to produce, because the main problem with the Kickstarter was that how I designed it made it very difficult to build, which at the time I didn't know anything about the difficulty in building it that I designed into it. So I'm either going to redesign it so it's easier to build quickly, or I'm going to stop supporting it. I probably will still do software updates for it, and then go to my next project, which is the filafactory. But I'm going to be going into the filafactory anyways. It's just whether I design the filafactory when I'm still producing the multi-struder, or I stop producing the multi-struder and I build the filafactory instead. So I either build both of them, or I build the filafactory. So the filafactory is basically version 2 of the multi-struder. I did an entire tour chat on that, 30 minutes talking about what the filafactory is, why it's come about. Actually, that one I think was 15 minutes. Why it's coming about, and the timeline on that guy. I believe I'm going to start designing it after August. After I start producing the Ecobase, I'm going to start designing version 2 of the filafactory. Filafactory is basically an easier to produce and nicer quality multi-struder. It's a better industrial design, but it's going to be more expensive, but it's going to be quicker and more precise. Okay, topic number 3, shredder. So I'm finishing the prototype at school. I run a club at San Jose State. It's called Maker Club, and the advisor of my club is the machine shop teacher. So I'm able to store stuff in the machine shop, and I've been doing that since I lost a tech shop here in San Jose. So I'm finishing the install of that guy. A lot of that was water jetted, so the water jet wasn't perfect on the squares, so I had to file some of them out. But because it wasn't plasmid, the inside square was not hardened, so I was able to modify that to with a file it down in order to get it to fit on the shafts. So now all I have to do on that guy is I need to get the bearings, push the bearings in using a arbor press, and then I also need to have two more pieces water jetted, which are the pieces that kind of give me some extra support on the bearings. And then a 1/4 inch piece that goes on top that gets welded down to support the bearings. Next one, so how on producing it. Right now I don't have any help at work. I talked to him. I talked to my boss, and he said that I showed him the file, and I'm going to continue to talk to him about it, but he said that there's that milling, because at the shop where I'm working at right now, I'm working at a machine shop, we only have mills. That's all we have. We have 1 horizontal and 3 verticals, and the 3 verticals are big enough to do the routing for the shredder, but it's just that there's a lot of forces involved, and holding down each individual piece is becoming a problem. So, and I discovered that when I was at Tech Shop originally, and I was trying to mill stuff out, and as you mill it out, even if you have tabs to hold it down, hold it to the sheet, as the sheet was cut, stuff was cut free, the sheet would lose its rigidity, and it would start to flex. And when it would start to flex, it would flex up and flex into the cutter and cause damage to the cutter as well as to the part that was being cut. So not good. I don't know if we're going to be able to find a way to start producing it there. If we do, it's going to be very slow. So my plan B, my main plan, and this has it could go either way here. San Francisco has reopened their tech shop. Now it's called The Shop, not Tech Shop anymore. It's called The Shop, and they are getting a brand new plasma, which I'll bring up here. It's called a Piranha Plasma. As you can see, they're really nice, really cool. So these guys, I don't know exactly, and this looks like a general video. I don't know exactly which one they got because there's a few options. There's either the C series or the high definition series. I don't know which one they got, and which plasma cutter they got for them, because I think these are all Hypertherms, Power Max. I don't know what this one uses. I'm going to try to call them again today before I head out to work to get some more details on that, but that right now is plan A, or plan number 1, is they're going to get this plasma cutter inside the shop within the next few months. I think they're going to be getting it in there next few weeks, and then they need to get, safety basics classes and train their staff on how to use it. So that's coming pretty soon. Then plan B for manufacturing the shredder is to buy a plasma cutter, CNC plasma cutter that's precise, that could do this kind of work. That inner square is the main problem, getting that inner square to be perfect. That is another option, is buying one for home, buy a 2x2 foot plasma cutter to work at home, or also at the school. I'm working on building one, but again, this needs to be precise on how it produces. So maybe what I'll do is I'll buy one, if I go with plan B here, and they take too long to implement the Piranha, is I'll build one, I'll buy one, and then while I'm building one, I will set that up, make it really precise, the one I'm building, and then once I get used to it, and it's dialed in where it's even better than the one I bought, I'll sell the one I bought. Because the one I bought is going to be at least $3,000 plus the plasma, so it's going to be at least $4,500, right? And I'm only selling the shredder. I have only been selling the shredder for $125 at this point. So for heat treating is going to be done at school in our kilns. We have some kilns at school. I'm getting access to those kilns, and then we're going to heat treat there. And then another thing I would like to eventually explore is building my own kiln, so we could do carbon nitriding, so we could get where they don't rust, where it's still steel, is not plated, so it doesn't wear off, but it still doesn't rust. Right? It's got a little bit more protection. Alright, so that's the shredder. Basically waiting on these piranhas to get at school so we could use them. I mean, not school, at Tech Shop San Francisco. And again, I'm perfectly fine with driving to Tech Shop San Francisco if it's going to save me $4,500, right? Especially if it's way higher detail than what I'm going to be able to do at home. And again, this also, I could do the 4x8 foot sheet, load it in there and cut, what was it, like 10 of them or something? So 4, it's 8. Cut 8 of them out at a time in 4 hours, especially if it's pretty quick, if it's a high amp plasma. If it uses like But generally what I would do is I would go down to the 45 amp because 45 amp is better detail. But if it's 125, you go way faster, but 45 is higher detail from my studying on plasma. Okay, Ecobase, and then again, so that those are the two options. If those two options don't work out, then I'm going to have to refund the project and figure something out. Figure out if I could still do the project, or if I could find somewhere else where they could build it for me, or whatnot. But the price that I have them set for is if I do it, not if somebody outside does it. Because obviously it's going to be at least $200 to have somebody outside just cut it. And I'm only selling them for $125, so right there I already lost $75. And then you have shipping, that's another $20, so right there I already lost $100 a piece. And you're not going to produce something if you're going to lose money on it. But I do not see that happening, especially if they get this machine at Tech Shop. I'll pay the $150 a month. I'll drive up to San Francisco. I'll buy all the material. I'll cut it there. If I could get it to do the precision, because I'm not going to generate a whole. I'm not going to waste a whole bunch of material doing crappy cuts again, like I did in Mid Peninsula Tech Shop in Redwood City. All right. So second to last topic, the Ecobase. Ecobase is a 3D printer, eco and price-friendly 3D printer. It's made almost entirely out of bamboo, steel, and aluminum. So really, really nice bamboo. There's going to be a few options. Again, there's going to be a Kickstarter on the Ecobase. There's going to be a few options like a really nice mural laser etched into the front of like a bamboo grove or some sort of environment photo or something, laser etched in the front. It's going to have options of heated bed, enclosure, really nice and eco-friendly enclosure. It's going to have at least a 9 by 9 by 9 print volume, 9 inch by 9 inch by 9 inch print volume, and because it's designed to fit in a flat rate box, so I know how much it ships for the Kickstarter. The flat rate box will hold 12 inch by 12 inch by 6 inches, so all the panels on it are going to be the 12 inch by 12 inch. And so I'm going to try to get as much print volume for you guys as possible out of it without increasing the price of shipping. Everything's open source. It all uses Marlin, whatever firmware you want. You can use Repetier, Marlin, SmoothieWare, whatever. I think there's probably going to be extra stretch goals where we go into ARM-based controllers instead of what are those called? AVR controllers. So those are all different options. But pretty much use whatever software you want, and it's going to have just standard open source hardware. I think it's going to be like an MKS board, maybe touchscreen, maybe Wi-Fi. Depends on the stretch goals. So that one I also did a full 30-minute video on that one as well. You'll find on my channel here soon. Future. Very last topic, filafactory, which we went over as the future. Then we have senior project. So this last year of school, mechanical engineers, which is the degree I'm going for, the bachelor, you spend an entire year working on a senior project with a team of up to 3 other people, I think. And my project is going to be designing a franchise for recycling plastic in third world countries. So it's going to be designing the business plan, designing all the machines for actual like big scale production, so not like home production. So basically the idea is I'm taking these 3 pieces, multistruder, the shredder, and the Ecobase, and I'm supersizing them for speed, for basically speed and repeatability and efficiency, right? So supersizing all these projects, and it's a year-long project, and that's starting in August. And then I need to work on the last piece is I'm going to be working on the shredder expansion modules, the funnel, and also a motor-powered shredder. And also another thing I want to work on is different sizes. Maybe a 12 by 12 by 6. Actually, it's 12 and 12 by 6.5 or 7 or whatever it's going to be, 7 inches. So work on different sizes of the shredder. As well. Anything else on the senior project here? Yeah, so basically it's kind of the idea, like, you know, when Honda, they build like the Formula 1 race car, they take some of the stuff they learned by building the Formula 1 race car and bring it into their regular consumer grade cars. So I'm building giant size of the multistruder, the shredder, or the filafactory, the shredder, and the Ecobase, and I could bring back the stuff I learned from building supersized ones that are very expensive to build. I could bring those back to the consumer grade ones, the filafactory, the shredder, and the Ecobase, and make those better that way as well. So it goes hand in hand, and I could develop a commercial based product while I'm getting credit at school at the same time. All right, that is pretty much it for this April 6th update. I just had plenty of information of things that came up that I just wanted to do a video version instead of a text-based version, and I will go ahead and finish this off, upload it to YouTube, get ready for work, and call up Tech Shop and see the status on the Plasma. All right, well, that is pretty much it for this video. Make sure you guys subscribe for those upcoming, when I get back home, I'll go ahead and upload those videos on the, the audio. It's going to be on YouTube, but it's just going to be audio of the of all the chore chats, the Ecobase, the filafactory, the shredder, multistruder, etc. All right, I'd like to thank you guys for listening, and I will catch you guys in those chore chats and later on. I hope to do this more often to inform you guys and do a lot of videos of the machines working that is in progress. Alright, thank you guys for listening and watching, and I'll catch you guys in the next one. Take it easy. Peace.